Okay, so P13.1, electromagnetic wave. So, I told you about waves, told you electromagnetic wave is a type of transverse wave, but it's a very, very special type of transverse wave, and the clue is in the name, electromagnetic. So what an electromagnetic wave is if you've got an electric field, it automatically creates a magnetic field at right angles to it. Okay, now the advantage of this is it can travel through a vacuum. It can travel through a vacuum. That's important because otherwise we wouldn't get light from the sun. And it's the fact that you've got this electric field created a magnetic field, which creates an electric field, which creates a magnetic field. So it doesn't need anything to travel through, it just keeps going. Okay? We'll do that when we come on to electromagnetism at the end. It's the very last chapter. But for now, what we need to know is, what is it? Well, we said it's a transverse wave, but it's a little bit more interesting than that. So what I'm going to draw now is I'm going to draw the spectrum. And what you can see is, you can see that here you've got really high frequency, and here you've got really low frequency, here you've got low wavelength, here you've got high wavelength, okay? And that's, and on here you could imagine that these waves here, they are very high frequency, very high wavelength, and these ones are very high wavelength, very low frequency. Okay, so and the way that I remember it is: real men inject Viagra, undergo extreme growth. Okay, and R for radio, M for micro, I for infrared, V for visible, U for ultraviolet, X for X-ray, G for gamma ray. Okay, and I remember real, and that was a year 9 student who came up with that for me. So real men inject Viagra, undergo extreme growth. Okay, and that's just a way of remembering the order. And in the next couple of lessons, what we're going to talk about is we're going to talk about some of the properties of some of these different wavelengths and frequencies of electromagnetic waves. All of these are all the same thing. They're all electromagnetic waves. The only difference between an X-ray and a radio wave is the frequency. So it's just different frequencies. So like different sounds have got different pitches, but they're still sound waves. Well, different electromagnetic waves have got different frequencies, but they're all still electromagnetic waves. Okay, and the last thing I want to tell you is, well, which ones of these have got higher energy, do you think? Well, these ones here have got higher energy, and these ones here have got lower energy. So it's something that you can observe just from knowing this, just from knowing that X-rays have got more energy than radio waves, and gamma rays have got more energy than microwaves, is that energy, they're both, so high energy, high frequency, low energy, low frequency. So that means that energy is proportional to frequency, which is something that's really useful to know in physics. Okay, so what else do we need to know about electromagnetic waves? They all travel at the same speed, and that speed is 3 times 10 to the 8 meters per second, but that means 8 zeros, and that is the speed of light in a vacuum. You can slow light down if it's travelling through something a bit thicker than a vacuum, such as air, then it'll be a little bit slower. Okay, but you can never go faster because you can't get less dense than nothing. Okay, so that is the speed that they will travel at if nothing is in their way. And they all travel at the same speed, 3 times 10 to the 8. It doesn't matter whether it's an X-ray or a gamma ray. It's exactly the same speed. The only thing that's different is the frequency.